Good morning, everybody. Hey, I just wanted to try and give you another installation of our SPSS walkthrough here. Again, you can go out to YouTube and get a lot of videos on how to run regressions or how to do different things in SPSS that are much better produced than this is. But I want to try and cover some of the things for our class in particular, and that way I know you'll be equipped to go. Okay, so you can use this video or you can just pitch it, whatever you want to do. But this is my data table here. That's what we're looking at right here. We're in data view. Basically, a couple things here. We're going to use SPSS for those of you that wanted to do the extra credit, we're going to use SPSS to do some regression. So here's what we're doing here. We're coming in and basically we're going here to analyze, okay? And we're going to come down here to regression. We could go to general linear model here, all right? And we could set up a couple different regressive type outputs if we wanted to. But for the simplicity of this class, I don't want to, okay? I'm going to come to regression, all right? And we're going to come here and I'm going to pick linear. Okay, and you're going to see here now that I've got a bunch of my stuff in here. Okay, so up here is my dependent variable. I exercise at least 60 minutes a week was my dependent and what I was doing. And I'm going to pull these guys out because they really have no value to us today because I'm going to change this all up anyway. So all I have to do is click them, highlight them, and just back them right out. All right, and I'm going to put some different guys in there for my independents to see what will line up for me. Now, what's critical here is I did a stepwise regression, and we'll probably do another one, and I'll show you what those are. But they're complicated in one sense because there's more than one procedure to analyze that. But what it does essentially and simply is it goes and takes a look at all your variables and develops the very best line fit for regression and predicting through several calculations. Okay, so I'm going to do that again, and we're going to put in a couple of these variables that I didn't use before, and just have a little fun with it for this particular exercise that we're doing. So I'm putting in these. I did so many over the weekend, it was driving me and anybody that was within sight of me pretty much insane. So I'm going to continue to do that here, and sometimes that's what you have to do to really get some good numbers. Okay, so I've loaded a bunch in, and the next thing we want to do is we want to look at statistics here. So what is it we want to measure? Okay, well, I have everything pretty much checked that I want. So without going into too much detail on the statistics, I'm looking at understanding what my estimates are going to be. So in other words, we're going to do a lot of averaging and a lot of sums of squares. We're also going to take and develop a standard line based on the hard data, and then we're going to do some estimates and predictions. Okay, so essentially those lines will follow the hard line and tell me if I'm normal or not, in a way. All right, that's one thing we want. The other is to develop a model fit. I want to see what the R-squared changes are. So R-squares we know is a relationship. So as we develop our models, we want to see how our relationships change. if there's a big change. I'm looking at part and partial correlation, so I can see in that relationship what does what, how much is a factor and how much is not on the variables. Okay, we're going to do collinearity diagnostics to make sure we're good. We're going to look at our residuals through what's called a Durbin-Watson test, and basically our residuals are our differences. We're going to make sure there's no systematic errors in there. Okay, so all these things we have not covered, and they are beyond the scope of the class, but they're easy reading, and I did provide some of those documents for you. All right, so we're going to click continue here. Okay, and then we're going to go to this thing called plots. Now, plots are important to me because I want to look at what my predictory plot is going to be and what my residuals are. Now, why is that? Well, it's going to tell me if I actually have patterns that are going off the beach. Okay, so I have a histogram coming with that with a normal probability plot. Okay, and I also have a standard plot. Okay, so I want a predictor and my residual plot, and I'll show you why that's important in a minute here. Okay, so we're going to click continue here. You don't have to do it this way. I did. You can see in here it says methods stepwise. Well, I've got a couple different methods I can do. I can make it as simple and just press enter. All right, I can remove them. I can do backwards. I can do forward. I'm not going to go into the basics of all those, but I use stepwise, and we'll talk about that in a second here. So I'm going to hit OK. We're ready to rock. So boom, takes me to my output page, and this guy is developing some charts. Normality looks interesting. Let's see what my plots. The first thing I do, and I'm going to have another segment on how to interpret, is I look at this guy off the chart. This isn't good when we see this. So this is telling me we've got some not a good fit on our model. So predictably wise, based on what the mean was, so a PP plot basically is a predictor and probability plot. And what this means is residuals versus actual are not exactly lining up well with what we would. So these residuals and these coefficients we'll put into a z-score, and we'll actually develop an output on that z-score, and that's where you'll see these plots here. Okay, they're off the chart, so they're saying that these guys don't have a very good what I put in there are not informing this particular study very well. And let's see if that's true. We got a good S statistic. That means we did have on our sums of squares, we did have more than we did with the residuals, so that's good. Very interesting. Looks like on the model, looks like we only got one model to work, and the only particular variable that was working was I make time to exercise each week. So that's fascinating. So on our stepwise, we only got one model, and this should show you some of the reasons why. These are excluded variables here. So the other variables, take a look at those t values and then look at the significance. None of those are significant. So in other words, without going into a lot of statistics, they're not informing this hardly at all. So that's why we saw that really bad plot we had. So if you see that bad plot, you got to take a look at what you're using for variables. All right. So hey, this is a down and dirty way of looking at this. I'm not scripted, and I'm certainly not reading off of any data sheets. I'm just trying to give you guys a basic primer. There'll be more about how to read these coming up, but that's the basics on how to do a quick regression, though. I hope it helped.